Today's lesson is on scientific notation. Scientific notation is just a way that we can write very, very large numbers or very, very small numbers. So here we have a very large number, and then instead of writing that number that way with that many zeros, you can write it in scientific notation, which is the same representation, just a little bit different. And then here we have a very, very small number that we can write in scientific notation instead. We are able to do this because both of them are being multiplied by a power with base 10. And think about any time you multiply a number by 10, what happens? So let's say you have 3.4, and if you multiply by 10, what you're really doing is just moving the decimal. So that equals 34. Or what if you had 3.4 and we're multiplying by 10 squared? That's 2 tens, or times 100. You move the decimal once and then one more time, so it would be 340. So we're basically writing it in a way that we're multiplying the front numbers by 10. So now let's go into our actual notes where you learn the proper form of scientific notation. Proper scientific notation is always a number a times 10 to the power of m. So, first, the number in front, a, it has to be greater than or equal to 1, but less than 10. And then m can be any number, both positive or negative. So, if it has to be in this form, let's look at a couple different examples and decide if it's proper scientific notation. Here are 3 examples, and we have to decide which one is actually in the proper scientific notation. So let's look at this first one. 32 times 10 to the power of 3. Is 32 in between 1 and 10? It is not, so this is not proper scientific notation. Is 0.6 between 1 and 10? No, it is not, because it's less than 1. Which leaves us with this last one. This is proper scientific notation because the front number is in between 1 and 10. So there we go. So in this lesson, we will be converting from standard form to scientific notation and then back from scientific notation to standard form. So standard form just means the regular number written out. So we're going to start with numbers in standard form and we're going to change them to scientific notation. So first, let's just write down the 4 numbers in standard form that we are going to change over. So 56,900,000, 9,040,000,000, 8,300, and then 4,092,000. So those 4 numbers are all in standard form. So we're going to write them in scientific notation. And scientific notation will either have positive exponents or negative exponents. All of these cases will have positive exponents because the numbers are all greater than 1. Once the numbers are in between 0 and 1, so the really, really small numbers, we will have negative exponents. So to write scientific notation, you always look at the front numbers, and we're going to put a decimal after the first number. 5.69, and we write all of the non-zero numbers. And then it's always times 10. Now we just have to figure out the exponent. The exponent is how many times that we have to move the decimal. Well, the decimal technically starts here, and we moved it in between the 5 and the 6. So how many times did we have to move the decimal? 1, 2, 3, 4, 5, 6, 7. We had to move it 7 times, so our exponent is 7. Common misconception is students just count the zeros, and they would write exponent 5, but it's how many times you move the decimal. So the next one if you put a decimal after the front number, 9.04, so even though we had a 0, because there were non-zero numbers after it, I'm going to include it. And then it's always times 10, and then to what power? How many times do you have to move the decimal? Here it's 3, 6, and then 9. Had to move the decimal 9 times. So for the last two, why don't you pause the video and see if you can figure them out on your own. You should get 8.3 times 10 to the third, and then you should get 4.092 times 10 to the power of 6. So standard form to scientific notation with positive exponents. Now let's move from standard form to scientific notation when we have exponents. Alright, so we are still converting from standard form to scientific notation, but all of these numbers will be between 0 and 1, which means we will have negative exponents. So let's write all of the numbers in standard form first, and then we will convert. So here are the four numbers, very, very small numbers between 0 and 1. So starting out 0.00985, we're going to write that number in scientific notation. Remember, the front number has to be between 1 and 10. So from left to right, you follow until you see the first non-zero number, which is 9, and we're going to put a decimal right after it. So 9.85, and then times 10 always. Count how many times we move the decimal. 1, 2, 3, but it's a negative 3. And the really cool thing with these examples, if you write the 0 in front of your decimal, then all you have to do is count your zeros. Because 1, 2, 3, negative 3. But that only works if you write the 0 in front of the decimal. So the next one, 0.00325, the decimal will be after the 3, so 3.25, and then always times 10, and then move the decimal 1, 2, 3, but it's negative 3. So now for the last two, why don't you pause the video and see if you can do them on your own. You should get 9.2 times 10 to the power of negative 4, because move the decimal 4 times, or you can count the 0, you have 4 zeros. And then the last one, you should get 6.7 times 10 to the power of negative 10. Now we are switching the direction in which we are changing our numbers. We're going to start with numbers that are written in scientific notation, and we're going to convert them to standard form. And for the first four examples, we will do all positive exponents. So let's write down all the numbers in scientific notation and talk about how to move them to standard form. Alright, let's start with the top one, 1.55, and that's times, not the variable x, times 10 to the power of 6. So whatever the exponent is, that tells you how many times to move the decimal place. So the decimal place is in between the 1 and the 5. We're moving it to the right, so we move it twice, which means we have to move it 4 more times, which really means we're going to, and every time we move it after that, we add a 0. So it ends up being 1, 5, 5, and then we have to add 4 zeros. And then we put our commas in, counting 3 from the right. So the number is actually 1,550,000. Alright, next one. The exponent is 4. So we have to move the decimal place 4 places to the right. Move it twice, and then we have to move it 2 more times, which means we're adding 2 zeros at the end. 5, 0, 7, and then add 2 more zeros, and then put your commas in, 50,700. Alright, why don't you pause the video and try the next two on your own. For the third one, you should get 2,040. And for the last one, you should get 720,000. Alright, same idea, except this time we will have all numbers in scientific notation with negative exponents. Alright, so when we have negative exponents, it just means that we are moving our decimal the other direction. Instead of moving them to the right, we will be moving them to the left. So 2, the decimal place is technically right after the 2. We move that decimal place 5 times to the left. And what it really means is you're going to have 5 zeros in front of the 2 as long as you put the decimal in between the first 2. So 5 zeros counting the 0 in front of the decimal and then the number 2. And then you can check your answer. So 1, 2, 3, 4, and 5. It was moved 5 times. So for the next one, the exponent is negative 2, so 2 zeros, decimal in between the first 2, and then 8, 9, 7. And let's see, the decimal was between the 8 and the 9, moved it 2 times to the left. So this one is pretty easy. Why don't you try the next 2 on your own? So you should get 0.000274. And then you should have 7 zeros, so 0.000000342. Alright, so for the last example using scientific notation, I'm going to give you 4 numbers that are written in scientific notation, but they're not the proper form. So we're going to change them to the proper form of scientific notation, and then we're going to list them least to greatest. So 4 numbers. 50.1 times